6.1, evaluate nth roots and use rational exponents. So here's an excellent little foxtrot comic for your amusement. Our whole lesson is really going to be summed up by this key thing right here. That b to the nth power equals a is equivalent to b equals the nth root of a. Let me break that down for you for a moment. Let's say that we have b squared equals a. Well, that is equivalent to b equals plus or minus root of a. And we learned that in our last section. The only thing we're going to be doing differently in this section is we're going to be using fractional exponents, which you may or may not have seen before. We can write this with fractional exponents, which actually make life a lot simpler. So instead of writing root a, remember that there's a little 2 implied up there when you don't write anything. And so that is equivalent to a to the 1/2 power. The cubed root of a is equivalent to a to the 1/3 power. And in general, the nth root of a is equivalent to a to the 1/n power. And I really like this because it makes a lot of sense. If you're one of those people that likes to understand it deeper this way, if we have, for example, x squared equals 16. Well, how did we solve this before? We took root both sides, and we got x equals plus or minus 4. But what we were really doing, I think, can be explained much better with fractional exponents because we wanted to undo x squared. In order to undo x squared, we rooted both sides. If I was using fractional exponents, I would have thought, let's do it to the 1/2 power. And that is why, remember when you have a power to a power, you multiply? That is why the square root of x squared is just equal to x, because it makes a lot of sense with those fractional exponents. Now, here, let's again be thinking b to the nth power equals a, and we're trying to solve for b. And so that was equivalent to b equals a to the 1/n, or the nth root of a. And you can just start writing with the fractional exponents. You do not need to write with this radical form. They're equivalent, and I really prefer the fractional exponents. Again, the way that I came up with this was I had b to the n equals a. So I figured if I just did this to the 1/n power, that would leave me with b, right? Because a power to a power I multiply, and so whatever I do to one side, I've got to do to the other, and so that's how I came up with this. And so now, one little new thing that I need to present here is that my answer is going to depend on if I'm taking an even root or an odd root. So as I always do, let's think of the simplest case. So let's think of b squared equals a in this case. And let's think of here b cubed equals a, because that's the simplest case I can think of for an even root, because this is going to leave me with b equals, remember we need plus or minus in this case, root a. And the simplest case here is going to be b equals the cubed root of a. And I don't have a plus or minus on this one, and I'll explain that as we go along here. So in this one, we need a is less than 0 first. All right, how about we just use -4? -4 for a would be less than 0, and I just randomly picked that. Remember that that would give me an imaginary number. In other words, I get no real nth root. But what about if I was doing the cubed root of, let's do -8 here. Remember, the cubed root is asking you what times what equals, in this case, -8. So what times what equals -8? That would actually give us one answer of -2, because a negative times a negative times a negative is a negative. It didn't work for the square root because I couldn't think of something times something which would give us -4. That's what the square root is asking us. And so I get 1 real nth root. What about if a equals 0? Well, root 0 is just 0. So I get 1 real nth root, which actually is always going to be equal to 0. Same deal goes with cubed root, doesn't it? The cubed root is 0. 0 times 0 times 0 is 0. And so, again, I get 1 real nth root, which is equal to 0. In this one, let's just say this is just equal to a to the 1 over n, right? If we're using the fractional exponents. What about if a is greater than 0? So let's try and solve this like we were doing before. B squared equals 4. Well, that would leave us with b equals plus or minus 2. And remember here, this is the question we're asking ourselves. And so plus or minus root 4 is equal to plus or minus 2. And so here I get 2 real nth roots, namely plus or minus a to the 1 over n power. Now what if the same thing I did with a cubed root? So in this one I'm asking myself b cubed equals 8. Well, b only equals 2 in this one because only a 2 times 2 times 2 gives me a positive 8. Remember, if I had a negative 2, that would have given me negative 8. So here I only have 1 real nth root, namely that just a to the 1 over n. I don't have the plus or minus deal when I'm solving. And again, this is just a presentation of it. Let's go and do some examples, and I think they'll make a lot of sense. So here, I am asking myself, I'm doing the 5th root. I could re-express this as negative 32 to the 1/5. So I'm asking myself, what times what times what times what times what equals negative 32? 1, 2, 3, 4, 5. Well, since I get a negative out, I know it's going to be negative something. Because now I have 1, 2, 3, 4, 5 negatives, which is a negative. And what about 2? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it looks like my answer is going to be negative 2. What about the 6th root of 1? This is asking me what times what times what times what times what times what? 1, 2, 3, 4, 5, 6 equals 1. Well, this one's simple. This is just 1. 1 times 1 times 1 times 1 times 1 times 1 equals 1. Now let's get a little bit fancy. Now we're going to do a root, and we're going to raise it to an exponent. So just in general, this would be something like root x cubed. Okay, what am I doing here? I have x cubed, but I'm taking the root of it. So now that's the fraction part. Another one would be, let's see, let's put a 5 here. Let's do an x to the 6th power. So the power part would be the 6, but the root part, which goes in the denominator of my fraction, would be 5. Let's do another one, cubed squared. So the exponent part is the 2, and the root part, which goes in the bottom, is the 3. So in general, this, if I was writing it with the radicals, this is saying take the nth root of a to the m power. And then here we have a negative exponent, so immediately let's just make that into a positive exponent by flipping it. So we have a to the m over n in the bottom now. And so this is just 1 over the nth root of a to the m. Of course, in this one, a cannot be equal to 0, otherwise we would be dividing by 0, which we never do in math class. Now, when we go to evaluate these things, okay, we just learned that this is the same thing as the cubed root of 125 squared. Now, the problem is, I'm not going to let you use your calculator for this problem. And I don't know which one of you wants to do 125 squared in your head or by hand. I certainly do not. So What I'm trying to say is stop thinking like this and think instead with the fractional exponents. And then, since we have fractional exponents, it doesn't matter if I write it like this or if I write it, let's do the 1/3 and then square it. Doesn't matter, right? Because again, if I multiply this out, power to a power, I multiply the exponents. They're equivalent. What I'm trying to say is, let's try and make this 125 smaller before we go and making it bigger by squaring it. So I can actually do the third root of 125 in my head, because 125 to the 1/3 power is just saying what times what times what equals 125. And I know that answer is 5. And so this part is equal to 5. So now I'm doing 5 squared, which is equal to 25. And now that's my answer. You see how I broke it down before I went building it up. Let me do another example. Let's not get scared by the negative exponents. Let's just put it in the denominator and make it a positive. Again, let me just look at the 8 to the 4/3. Okay, I'm going to think about this as let's break it down before we build it up. And breaking it down, I'm saying, okay, this is breaking it down, right? Because this is making the number smaller. Because I'm saying what times what times what equals 8. Well, 2 times 2 times 2 equals 8. So this part's going to be 2. And then I have to do that to the 4th power. And 2 to the 4th power is 16. So let me go back to my original question, which is 1 over that answer that I just got, 1 over 16. And that is my final answer. Now, these are just problems you're going to do in your calculator to make sure you know how to do them. So I would suggest taking out your calculator and making sure you get the same answer as I do. So I'm just going to do 22, and then I'm going to use my power button. So that's that button. And then make sure you put the parentheses, otherwise you will get the wrong answer. So you want to do it to the 1/4 power. On your calculator, you should get 2.17. On this problem here, all I'm going to do is 35, then I'm going to hit that power button, 5/6 power. The parentheses are very necessary, and my answer should be 19.35. Whenever I see a problem like this, I'll just rewrite it with my fractional exponent. So 11, what am I doing to the 11? I'm doing it to the 4th power, and the radical part, which goes in the denominator, is 5. And so on my calculator, I'm going to do 11 to the 4/5 power. And so I should get 6.81. Remember again, this is the power part, goes in the numerator, and the radical part goes in the denominator. When we want to solve problems like this, just like we were doing with the square root, the most important thing is to isolate whatever the power is first. And so I mean that I need to get rid of this 6. So divide by 6. So important, isolate the x cubed first. 384 divided by 6 is 64. So I know that x cubed equals 64. I'm asking myself what times what times what equals 64. And I know that answer is 4. In other words, x equals 4. I only have one solution there. That's it. In this one, I've already isolated. You see how I've isolated something to the 5th power? So I have nothing to divide by first. I can take the 5th root of both sides. So I'm asking myself here, what times what times what times what times what equals 100? Well, personally, I have no clue. So I need my calculator here, okay? I really need my calculator to figure out this part. So I'm going to do in my calculator 100 to the 1/5 power. And I get 2.5 2.5119. And so basically, I've just done the fifth root of 100. So I know that the x minus 8 is equal to 2.5119, right? Because I took the fifth root of both sides. And so now I have to add 8 to both sides to get my final answer of x equals 10.5119. Finally, an exercise ball is made from 7,854 square centimeters of material. Find the diameter of the ball. So they tell me to use this surface area formula. So I know that the S part is equal to 7,854 square centimeters. And if I was confused about what this was representing, look at the units. The units tell you the answer. Since they are in units squared, I know that must be my surface area because, of course, my radius is going to just be measured in centimeters. And so I want to find the diameter of the ball. So I need to keep that in mind. I'm going to be solving for radius here. All right, so I know that 7,854 is equal to 4 pi r squared. And remember I said that it's so important that before I start, I have to isolate whatever letter is squared. And in this case, it's just the r squared. I have no parentheses. So I really have got to get rid of that 4 pi. I'm going to divide both sides by the 4 pi to get rid of it. So in my calculator here, I'm going to type 7,854 divided by, and then I'm going to put parentheses, 4 pi. Do not forget those parentheses, otherwise you will get the wrong answer because your calculator automatically does order of operation. So it's so important that you put those parentheses. So I get 625.0015 on my calculator, and that is going to be equal to r squared because I divided by the 4 pi. And now I need to take the root of both sides. So I'm actually going to pull up my calculator to show you a real quick trick. Okay, so again, so far what I've done is 7,854 divided by, and then I put parentheses around the 4 pi. Do not forget the parentheses. Press enter. And now I need to take the square root of it to get my answer. And so the easiest way to do this is you want to do the square root of what your answer just was. So there's this answer key. I don't know whether you've used it or not, but the answer key basically brings up whatever the answer was to my previous line. And so I want to do the square root of answer, second answer, all right? And that is going to give me the square root of 625.00141615 without me having to type it all in again. So remember, when I take the square root, I get two answers. So I'm going to say r is approximately plus or minus 25. And that is, the squigglies is for approximately. But of course, the radius can't be negative. So I can cross out my negative answer and just get 25. Remember, though, they're asking me for the diameter. And the diameter is equal to 2 times the radius. So 2 times 25. So I get 50, but remember I rounded, so I'm going to say about 50, and my units are centimeters. And that's it for this lesson.
Bye.